Day 1, Problem 1. Part A. Rewrite the number into standard form. I'm going to begin by copying that number down. It is 2.051 times 10 to the negative 8 power. And to change it to standard form means that the decimal point needs to be moved. Now, if I move the decimal point to the right, that would create numbers that are larger than 2.051. If I move the decimal point to the left, I'm going to create numbers that are smaller than 2.051. And the question is, when the exponent on a 10 is a negative number for an exponent, what sort of thing do I want to accomplish? Do I want to create numbers that are larger than what I see here or smaller than what I see here? And when the exponent on the 10 is a negative number, I know that my goal is to create a standard number that looks smaller than what's here. I'm going to move this dot to the left. And because it's negative 8, to the left 8 spots. One spot to the left takes me in front of the 2. And now I have 7 more spots still to go to the left. And all of those will end up being filled in with 0 placeholders. When I get done moving all the way to the left, I will get point and then 7 0 placeholders. So 1, 2, 3, 4, 5, 6, 7. And then the digits 2051. 2051. This is a number that's in standard form. It is a very small number, a very tiny decimal number, and it is the normal way to write this number here, which is in scientific notation. Now part B. Rewrite the number into scientific notation, and the number is 0.000023. I'm going to start by writing that down. 0.000023. I want to write this in scientific notation. So when I do this, I want to have one non-zero digit to the left of the dot, and then it's going to have a times 10 and some sort of exponent on the 10. To have one non-zero digit to the left of the dot means that the decimal point will need to go here, so that the digit 2 is my number that's to the left of the dot. To get the decimal point here means that it needs to move 1, 2, 3, 4, 5 spots. That will create 2.3, and then times 10. I moved it 5 spots, but recall the difference between using positive exponents and negative exponents on the 10. Numbers that are these small decimal numbers are the ones that involve negative exponents when in scientific notation. So this is negative and then the 5 from the 5 spots. Now, day 1, problem 2. Solve this equation, and then part B, check the answer. So first thing, copy the equation down so that we can work with it. Here is a line downwards from the equal symbol, and we're going to begin. On the left side of the equation is where the variable a is located. We'd like to solve this for a by removing any other numbers that are on that side of the equation. One of the things on that side of the equation is the 10 times the part of the problem with the parentheses. And so we could multiply 10 times the a and also multiply 10 times the 1. That double multiplication is called the distributive property. 10 times a is 10a, and 10 times negative 1 is negative 10, and that is equal to 16. Here is the a term. Next to the a term is minus 10, And the opposite math of minus 10 is to add 10. So underneath, add 10 and add 10. The 10a comes straight down. Negative 10, add 10 makes 0, and equals 16, add 10 is 26. Now I'm going to remove the coefficient 10 from in front of the a using division. Divide by 10, divide by 10. 10 divided by 10 makes 1a, and that is equal to whatever 26 divided by 10 makes. Now 26 divided by 10 could be written as a fraction, or we could use long division and figure out 26 divided by 10 as a decimal. It doesn't matter which is done. The fastest thing to do is probably to leave it as a fraction. 26 over 10. 1a is the same thing as a, equals 26 tenths. 26 tenths is a reducible fraction. The top and bottom are both even numbers, and so they can both be divided by 2 to reduce them to smaller numbers. 26 divided by 2 is 13, and 10 divided by 2 is 5. We think that the solution for A is the fraction 13/5. Now in part B, let's check if that is correct. So 10 parentheses, in place of the variable A, substitute 13/5, and then subtract 1, parentheses equals 16. Does this equal 16, we wonder? Let's do a little bit of work in the parentheses first. The whole number 1 is equivalent to 5/5. And so if I think of this as 5/5, I can figure out 13/5 subtract 5/5. 13/5 subtract 5/5 is 8/5. Is that equal to 16, we wonder? Well, 10 times 8 is 80 fifths. Is that equal to 16, we wonder? Well, what is 80 divided by 5? Okay. On a piece of scrap paper, 80 divided by 5, is that 16? So 5 divides into 80. 5 divides into 8 once. 1 times 5 is 5. Subtract 3. Bring down the 0 to make 30. And 5 divides into 30 6 times. 16. And so we wondered, is 80 over 5 equal to 16? It is. This checks, and our answer for A was correct.